Okay, in this video, we're going to use implicit differentiation to solve this problem. Now, the purpose of this video is to highlight one very important concept with implicit differentiation. And that's why I chose a very simple problem. In fact, we're actually going to do two very simple problems. So, one way to solve this problem, what if we go ahead and multiply this piece by x and this piece by x? We know x divided by x is just 1. It cancels out. So, what we have is y is equal to x. So what if we take the derivative? We get y prime is equal to 1. So we're saying that dy over dx is equal to 1. This is an answer. I'm going to call this option 1. So one way of doing it. Now let's do option 2. Now option 2, what if we go straight in? We use the quotient rule. Low d high minus high d low divided by the square root of what's below. So low meaning the denominator. So x times derivative of our numerator. So we'll say y prime minus high, so the numerator, times the derivative of our denominator, and the derivative of x is just going to be 1, divided by the square root of what's below, so divided by x squared is equal to. Now the derivative of 1 is just 0. So 0 times x squared is just 0, so we get x times y prime minus y times 1, so just y, is equal to 0. So we want to isolate y prime, so we can get x times y prime is equal to y. All we did was add y here, add y there. Finally, we get y prime is equal to y divided by x. So we can say we have dy over dx is equal to y divided by x. And we can call this option 2. Now, obviously, you'll say that these two things are different. This is 1, this is y divided by x. It's like saying, what if y is 5 and we say x is 2? 5 divided by 2 is not equal to 1. Obviously, they're different. It's important with implicit differentiation, we have a relationship given the original equation. Our original equation is y divided by x is equal to 1. That's our original equation. So our original equation is like this. Y is equal to times x times x. So y is equal to x. Now, if I see a y right here, I replace it with an x. I get x divided by x, which is 1. They're the same. Likewise, if you like plugging in a number, let's say x is 5. Y is equal to 5 then. So if x is 5, so is y. 5 divided by 5 is 1. They're the same. Now, let's say you say, oh, maybe this was just a coincidence. We can do another very simple problem to also highlight this point. So let's do this problem. Y divided by x is equal to x. So again, we'll do two options. We'll multiply this piece by x times this piece by x. And this will be our option 1. We will get y is equal to x squared because the x's cancel out. Then we could take the derivative and we could say y prime is equal to 2x. Take the derivative of this piece, which is just 2x. And so we end up getting dy over dx is equal to 2x. Again, we can highlight this as option 1. And then we'll do option 2. Now, option 2 is what a calculator would typically spit out, because what you're doing right now is going straight and using the quotient rule. So we'll do low d high minus high d low divided by the square root of what's below. So low, meaning the denominator, times d high, the derivative of our numerator, minus high, the numerator, times the derivative of our denominator, divided by the square root of what's below. So x squared is equal to, the derivative of x is just going to give you 1. So we get x times y prime minus y, derivative of x is just 1, divided by x squared is equal to 1. Okay, we can multiply x squared here, multiply x squared there. We get x times y prime minus y is equal to x squared. We'll add y here, add y there. We get x times y prime is equal to x squared plus y. And our final thing, divide by x, and we get y prime. Save a little bit of space. I'm going to say we have dy over dx is equal to x squared plus y divided by x. And we can label this as option 2. Now again, here it has no y. So if I make up something, I say x is 5, and y is 2. I'm just making up two variables. I put a 5 here, I get 10. I put a 5 here, I get 5 squared 25. 25 plus 2 is 27. 27 divided by 5 is not 10. That's why it's a very important thing to remember. We have a relationship from the very beginning. You can't just pick 5 and 2. it actually does matter. So for example, I could say x is 3. I can't just randomly say y is 5. I can figure out what y should be based on the original equation. So if x is 3, then I know the y value will equal 3 times 3 is 9. We can think about this. 9 divided by 3 is 3. So that could be one relationship. Because this is the last problem, let's pick another point, just so it's obvious. Let's say x is equal to 4. 4 times 4 is 16, so y is equal to 16. So 16 divided by 4 will give you 4. Now we can test it out. So we're going to try option 1 and option 2. So option 1, let's try 3 and 9. So if x is 3, I'm going to get 6. Now let's try this one. X is 3. 3 squared is going to give me 9. Plus y is 9. So 9 divided by x, which we said is 3. 9 plus 9 is 18. 18 divided by 3 is 6. So they're a match. Now again, just to prove that this is not a coincidence, we try 4 and 16. So if x is 4, 2 times 4 is 8. And then we do 4 squared, we get 16 plus y is 16. So 16 divided by 4. 16 plus 16 is 32. Divided by 4 is 8. So it's a match. That's pretty much it for this video.